Welcome to a lesson on imaginary numbers. So you're probably wondering, like, what are imaginary numbers? Or more specifically, why are we going to care about numbers that don't actually technically exist? What's the point? And the point is it allows us to deal with hypothetical situations that may not make sense on paper, but they can be applied to situations in real life, such as like in engineering and other more advanced things. Um, and it lets us deal with situations that our human mind can't so simply comprehend, but with the right calculations, it lets us create results that we want. And you're probably wondering, okay, what are imaginary numbers? What is this? What are you talking about, Mr. Porter? Well, here's the thing. Say you wanted to find the square root of negative 16. You can't, right? There is no such thing as the square root of negative 16. And that's because of the negative number. Um, and that is absolutely because there are no two numbers that multiply. There are no numbers that are the same that multiply get negative 16 because of that negative. But I could find the square root of 16, not the negative, right? So if I take away the negative 1 and put it to the side, I can find the square root of 16, which is going to be 4. And then I have the square root of negative 1. So I can find the square root of negative numbers if I take the negative out and put it to the side. And so we're actually going to represent the square root of negative 1 as I for imaginary. So effectively, this becomes 4i. Just to show you guys a few more examples of this, square root of negative 4, square root of 4 is 2, right? So this is 2i. Square root of negative 100, square root of 100 is 10, so that's 10i. Square root of negative 64, square root of 64 is 8, because 8 times 8 is 64. So because of the negative, it becomes 8i. So on and so forth. So we have to keep that in mind. Now, what I want to show you guys besides this, right, this concept, is what if we start involving exponents with I? And there's a very interesting pattern that ends up showing up, and I'm going to show you guys what happens. So I to the 1, anything to 1 power, right, is just itself. So we're just going to leave that as I. But watch what happens when we square I. I squared is the same thing as the square root of negative 1 squared. And if you square a square root, it ends up giving us just negative 1 because they cancel out because they're opposite. So that's interesting. I to the 1 is just I squared gives us negative 1. Let's try and take this a step further. Let's find I to the 3rd power. If you guys remember your law of exponents, that's the same thing as I squared times I1. 2, 1 is 3, right? 2 plus 1 is 3. So we know what I squared is, right? I squared, we did the previous time, is negative 1. And we know what I to the 1 is. That's just I. So this becomes negative I. So there's still not a pattern here, but we'll notice that you might see a hint of it at this point. Let's find out I to the 4. I to the 4 is just I squared times I squared, right? 2 plus 2 is 4. And we know I squared is negative 1, so that's negative 1 times negative 1. And that creates a 1. See this, guys? It loops. I, negative 1, negative I, 1. And then if I found another 1, it would just loop back to I to the 4 and a single I. So I want to shorten this right here. This is what you have to remember, guys. In fact, I would write this down, use it as a reference for the future. You can always use that in your notes, but I would absolutely write this down. And just keep in mind that, if I to the 4 is 1, if you remember your law of exponents, that's the same thing as I to the 0, because anything to the 0 power is 1. So with all this information, we can actually find out what the value is for like I to the 25. Because 25 is a bunch of 4s that turn I into a 1, and then some leftovers. So to give you an example of this, if I wanted to simplify this, I have to ask myself, okay, if I take the number 25 and divide it by 4, what's that going to give me? Well, how many 4s go into 25? Putting that in your calculator, guys, you're going to get 6 and a little bit of leftovers, right? So 6 times 4, this is actually some elementary school stuff. 6 times 4 is 24. And I'm going to subtract this, and I get 1. 1 is my remainder. So it turns out, guys, that I to the 25 is a bunch of 4s, 6 4s exactly, and then 1 as a remainder. So it gives us I to the 1 because of this loop that we see. I to the 1 is just I, and we're done. So all you really have to do is take the exponent for any I, divide it by 4, find out what the remainder is, and that's how you use this chart right here. Let's go ahead and do one more. I to the 40. Let's take, once again, we have to think about how many 4s go in there. You probably already can tell, right? How many 4s go into 40? We know it's going to be 10. And if I do 10 times 4 is 40 and subtract it, there's going to be no remainder. So look at this. I to the 0 is 1. So this is going to give us 1. And that's a very nice little shortcut on simplifying expressions with just I to the something power. And you guys will be doing that at homework today. So we'll give you guys a chance to do, this is practice, but there's going to be one more video, so make sure you watch that, guys. Have a good day. Bye.